Yes, Assalamualaikum and very good morning. Can you hear my voice and see the slides?
Waalaikumsalam, dengar sir.
All right. Okay. So welcome to the first class of Dynamics. This is BTD1222. My name is Muhammad Hasnun Arif bin Hassan. You can call me Hasnun. So I will be teaching this class, section 1. So there will be two sections of Dynamics. One is taught by me and the other one is taught by Dr. Nur Izatul. So today will be the introduction class, and we will also do some tutorials, which is the basic, the fundamentals of what you need for the first chapter. Okay, so before we go on with the introduction, I would like to introduce myself. So again, my name is Hasnun. You can call me Hasnun. My room, in case you need to come and see me later when you are in campus, is in block 4B at the back, above the welding lab. I hope you know where welding lab is. This is my phone number. I hope everybody is already in the group. So in case you have any question, you can send me a WhatsApp message. Also, there is my email address if you need to send me anything later, maybe the assignment, but the assignment normally will be uploaded in Kalam, so there might be no need to send anything to my email address. And you can also WhatsApp me by typing this address in the web browser. Okay, so a little bit about my background before we continue with the class. So I did my first degree in Germany in mechanical engineering. And then I came back to do my master's in University Malaya. And then I did my PhD in UMPSA and graduated in 2016. So since then, I have been teaching in UMPSA. So this is my 10th year at UMP. Okay. This is the course detail, Dynamics BTD1222, which means that this subject has 2 credit hours. Okay. Prerequisite is statics. I hope everybody has already passed statics, or at least you have transferred credit for statics. And this is the WhatsApp group for this class. So any communication will be done through this group. So I hope everybody has joined the group lah, so you do not miss any announcement or any information that I will give you from time to time. Okay. The synopsis of the class. So what we are going to learn in these 14 weeks. So if you read here, the course covers rigid body, kinematics and kinetics. So this is what differs from dynamics that you learn during your diploma. If you any of the students here come from diploma level, in diploma you learn about particle. So particle is basically an atom lah, atom size, a dot. So we treat every object as a particle, as a dot. If you, let's say, calculating a car, a movement of a car, so you will treat the car as a particle, a dot. But this is not the case with dynamics for degree, where we treat the object as a body, as a rigid body, meaning that the object will not only travel left to right, right to left, up and down, and so on. That is what the typical motion of a particle. But for rigid body, the motion of a body, it can travel left, right, up and down, but it can also have rotation. So that is the difference between particle dynamics and rigid body dynamics. Okay, and you see there are 2 words that have been highlighted. One is kinematics, the blue colored one. So kinematics is basically the character of a motion. When we talk about a person, for example, the character of a person, it can be the hair color, it can be the eye color, it can be the skin, it can be the height of a person. Those are the character of a person. A motion also has character. So how do we characterize a motion? One is the position. So an object, it changed or it starts from position A, for example, moving to position B. So there is position involved. So that is one character of motion. And then the object is moving at certain velocity or speed. So velocity is another character of a motion. For example, if you take a car travels at 80 kilometer per hour. Another car is traveling at 100 kilometer per hour. So that is another character of motion. So velocity is another character of motion. And also acceleration. So when the car is moving at faster speed, as the time change, the speed becomes faster. So we say that the car is accelerating. So the velocity is no longer constant. Velocity is increasing, or when the car is braking, for example, the velocity decreasing. So these are called acceleration. So this is another character of a motion, which also belongs under kinematics. And another component of character of motion is also time lah. How many time is taken to move from one position to another. Okay, so kinematics, the blue color one, is the one that we will cover in the first chapter of the class. And then we also have the green colored word, which is kinetics. So if kinematics refer to the character of motion, kinetics refer to the force that is causing a motion. Everything that is moving, there must be a force acting on the object. So there are three methods that we can use to solve the force-related problem. One is the force acceleration method that will be covered in chapter 2. And then we have work and energy method, and also impulse and momentum method. So this work and energy and also impulse and momentum will be covered in chapter 3. Okay, and then if you read to the end, it says solve the kinetics problem of two-dimensional planar motion. So meaning that in this class, we will only focus on two-dimensional problem. We will not go into 3D problems. So you will be calculating the problems in this class, in the test and so on, with only referring to X and Y axis lah. Basically, we are talking about two-dimensional problem. Okay. So as I mentioned earlier, this class is divided into 3 chapters, or we also call it as course outcomes. Okay, so the expectation is that when you finish dynamics, you will be able to understand these 3 outcomes lah. So these 3 outcomes you should be able to achieve. So the first outcomes will cover the kinematics, the character of motion. So we will analyze linear velocity and acceleration of a point, and also angular velocity, which means the rotation component, and also angular acceleration of the remaining links. So this is the difference, as I said, as compared to dynamics that you learn in diploma. Dynamics in diploma only involve linear velocity and acceleration, but in dynamics for degree level, we have another 2 parameters, which is angular velocity and also angular acceleration. Okay, angular velocity is given by the symbol omega. It looks like a W, but it is called omega, a Greek letter. And angular acceleration is given by the letter alpha. Throughout the class, we will see a lot of this symbol. Linear velocity, V, linear acceleration, A. So you need to know V, A, omega, and also alpha. So these are 4 main parameters that we will calculate in the class. Okay. Second course outcome, or the second module, is to apply the Newton's second law of motion. Okay, I hope everyone knows that the Newton's second law of motion is given by the equation F equals to ma. I think you should already heard of this formula before in physics, in high school, in secondary school, you learn about this already. F equals to ma. We will make use of this formula, of this equation. This is called the Newton's second law of motion equation to determine the acceleration A, and also the angular acceleration, which is alpha of a body, of an object. Okay, and in the last course outcome, or the last module, module number 3, we will apply two methods or two principles. One is the principle of work and energy, and the other one is the principle of impulse and momentum. This time is to calculate velocity v and also angular velocity, which is omega of an object. Okay, so we have 3 chapters to be covered throughout these 14 weeks. Okay. And the most important thing is, how are you going to be assessed in this class? Okay, so every chapter or every course outcome will have 3 assessment: quiz, assignment, and test. So as you already know, maybe some of you has already know about this, that this dynamics course does not have final exam. So our approach in dynamics is that after we finish every chapter, we will straight away do a test. So this test is equivalent to the final exam, which means that when we finish chapter 1, we will do test 1, which will cover all the topics in chapter 1. So test is the level, the difficulty level is similar to the final exam. When we finish chapter 2, we will do test 2. And when we finish chapter 3, we will do test 3. So you can see here, test 1 contributes 30% of your final mark. Test 2 contributes 20%, and test 3 contributes another 20%. So if you add up these 3 tests, you will get 70% of your final marks coming from the test. So throughout every topic, every chapter, we will also have quiz, which will be conducted in the class, face to face lah. And we will also have assignment. So assignment will be uploaded in Kalam. You will answer at home. You can write in your tablet if you have. You can write on a paper, and then you will scan the paper and upload your answer in Kalam as well. So assignment will be conducted through Kalam, quiz will be conducted in the class, and tests will be conducted probably at night lah, because we have 2 sections. So we need to put everybody together in a room and do the test. So tests probably will be conducted at night together with another section, which is section 2. Okay, I hope the assessment is clear. So altogether, you have 100% marks. 70% comes from the test, 15% from quiz, and another 15% from the assignment. So quiz and assignment, I hope all of you can get as maximum as possible, so that it will help you to get good marks lah. Okay. So that is the assessment. Any questions so far on the topic and also the assessment? No question? Okay. So let's go to the class planning. All right. As you already know, that we will conduct the first 3 weeks online of the class. So today is the first class, which we will cover position vector after this. And then we will continue about 4 classes online through MS Teams, like this. I will share the link. I mean, the link that I have shared in the WhatsApp group, that will be the link for every class. Okay, the link will not be changed. So you can already click on the link to join the next classes lah. I also have put the link in the WhatsApp group description, so it is easy for you to click on that. Okay, next class on Wednesday, we will cover relative motion analysis velocity, specifically on rotation motion. And then next week, still online, we will cover relative motion analysis velocity with general plane motion. I will then later explain what is rotation, how rotation occur, and also what is the definition of general plane motion. And then Wednesday next week, we will cover the instantaneous center of zero velocity. And the week after that is the Hari Raya week. So on Monday is public holiday, Hari Raya Aidilfitri, the third day. So there will be no class. And on Wednesday, I think everybody is still in holiday mode, still in your kampung. So we will do the class, but through Kalam. So I will upload some tutorial videos in Kalam so you can refer, and also I will upload assignment 1, which you can do anytime during the Hari Raya break lah. So basically, we will have a class again on week 4 after the Hari Raya week, which then it will be a face-to-face class lah. So 30th of March, Monday, we will go into relative motion analysis acceleration. And Wednesday, 1st April, is another relative motion analysis acceleration, face-to-face. And we will do assignment 1, as I said, during the Hari Raya break. You can do the assignment anytime that you are comfortable with during the break. I will also upload some tutorials in Kalam. You can refer to do your assignment. And then we will do quiz face-to-face in the class. So basically, we will try to cover the first chapter in about 4 weeks. Okay, in about 4 weeks, 2 weeks of online class through MS Teams. 1 week is basically off week lah, no classes. But we have one assignment and also online video in Kalam. And the 4th week, we will have face-to-face class to finish the first chapter. So this is the planning for week 1 until week 4. Okay, any question on this so far? Okay, if all clear, then we will go into the second chapter. So second chapter will also be covered in about 4 weeks, where all the classes will be face-to-face. This time around, you will be in campus already. And notice that in week 5, we will have test 1. Test 1 comes from chapter 1. But we will do the test probably in week 5 at night lah, together with the other section. So I put test 1 here, but it is not on Wednesday during class time, but it is probably at night throughout the week lah. We will find available slot where the room, the DPM is available, and we will do the test there. Okay. So week 5, we will start with the first subtopic of chapter 2, which is equation of motion translation. We will cover this in 2 classes, 2 days. And week 6, I have a trip to Japan. So there will be no class, no face-to-face class, no online MS Team class, but I will upload the material, the tutorial, and also the video class video in Kalam. So you will watch the video anytime that you are available. And also there will be another assignment. So you will do assignment during my trip lah, during week 6 when I am away from UMP. So this will be the week that you do assignment 2 and submit in Kalam. In week 7, we will continue face-to-face class, equation of motion, the second subtopic, which is rotation. And we will do quiz 2 here in week 7. And then there will be a mid-semester break. Okay, probably all of you will go back home. And then you will come back week 8. We will do the last subtopic of chapter 2, which is equation of motion, general plane motion, also face-to-face. So basically, chapter 2, majority of the chapter 2 will be conducted face-to-face, except for week 6 that will be, some materials will be uploaded in Kalam and you will do your assignment. Okay, so these are 4 weeks of chapter 2 that I am planning to do with you lah. Okay, any question on chapter 2? All right, so if there's no question, let's move on to week number, to the last topic or last chapter, where we have a lot of holidays, public holiday, and also there is another week that I am away from UMP. So we will cover the last topic in about 6 weeks. You can see here there are 6 weeks, but actually we have only about 3.5 weeks or 4 weeks of classes, 3.5 I think, because there are a lot of public holidays towards the end of the semester. Okay, so week 9, we will cover chapter 3, work done and kinetic energy, and also principle of work and energy, 2 classes. And then week 10, we'll go into the conservation of energy. You also see here, week 9, we will have test 2, which comes from chapter 2. This is also not on Wednesday during class, but it will be during week number 9 at night together with another section. Okay, week 11, this is the week where we have Hari Raya Aidil Adha. The Hari Raya will be on Wednesday, but on Monday I am away, so there will be no class. And as usual, I will also upload materials in Kalam, videos and also some tutorial video in Kalam. You will refer to Kalam for the class on Monday. Wednesday, no class because of Hari Raya Aidil Adha. And Monday next week is also a public holiday, which is Hari Keputeraan yang di-Pertuan Agong. So we will not have class week 11 and also the first day of week 12, no class. We will have our class face-to-face again on 3rd of June, okay, where we'll go into momentum. So you can see that the first 2 weeks, week 9 and week 10, we cover the work and energy method. And another 4 classes, we will cover impulse and momentum method. Okay, so 3rd of June, linear and angular momentum. Week 13, principle of impulse and momentum, 2 classes we will cover in both Monday and Wednesday. And week 14, again, we can only have 1 class in week 14 because on Wednesday is another public holiday, which is Awal Muharram. So we will not have class on Wednesday. We will finish our class on the first day of week 14, which is Monday. Conservation of momentum will be the last class of the semester. And then during week 14 also, before you go back for study week leave, we will have test 3. Probably not on Wednesday because of public holiday. Maybe we will do it on Thursday at night. Okay, so this is the planning of the class. So any question on the class planning? Probably, yes, any question?
No, sir.
Okay, so probably there will be some changes here and there. This is just a planning, but we will try to finish all the topics that I have listed here throughout these 14 weeks. Hopefully we can do it together. Okay, so the last thing of the introduction before we go to the topic that I want to cover today is the reference book for this class. So we will use probably the content of this class is coming from this book, which is Engineering Mechanics Dynamics 14th edition by Russell Hibler. So if you, it is not compulsory for you to buy this book. If you have, it is good for you because you can do some extra tutorials, extra questions in the book. But To me, it is enough if you follow the lecture and you refer to all the materials that I will upload in Kalam, all the notes, the slides. That should be enough for you to score or to get good marks in the class lah. But if you are able to buy this book, then it will be beneficial for you. You can do some extra tutorials from the book. So if you do have the book, you will notice that there are many chapters in the book. I think it starts from chapter 12 until 20 or 21, something like that. But the topics or the chapters that will be covered in this class is only 4 chapters, which is 16, 17, 18, and 19. The chapters before, which is 12, 13, 14, 15, I guess it is for dynamics diploma, which is particle dynamics. And chapter 20, if I'm not mistaken, is not covered in degree level. It is more advanced topics. Okay, so that's all for the introduction of the class. I hope you are clear about the topics that will be covered in the class, the assessment that will be used to evaluate you in the class, the class planning, how are we going to cover all the topics within these 14 weeks, and also the reference book of this class. Okay, so if there's no question, let's continue with the lecture, the topic. Let me share the screen again. So the session today is recorded and I will upload it in Kalam. I will make the Kalam available probably on Wednesday, because after this class I need to go to KL for some visit. So I will be back tomorrow, and then I will upload the materials in Kalam, and then you can refer to Kalam probably by tomorrow or Wednesday. Okay, you can see the slide now, position vector.
Yes, can sir.
Okay, good. Okay, so this will be the first topic that I would like to cover. Please pay attention, because this is basically the fundamental of the topic that will be covered throughout chapter 1. So if you do not understand position vector, then you will have difficulties to solve the problem later in chapter 1. Okay, so before we go into the position vector, let's look at the subject overview. Okay, so basically we are currently learning dynamics. So dynamics is basically under the branch of engineering mechanics. There are some other topics under engineering mechanics, which is rigid body, deformable body, and also fluid mechanics. So we are currently under rigid body, where you already learned statics during your diploma. And then we have dynamics, as I've explained before. Under the branch of dynamics, we have kinematics, which is the character of motion, and also kinetics, which is the force causing the motion. So what we are learning today and for the next 4 weeks is basically the kinematics, this branch, which is CO number 1, cause outcome number 1. Under kinematics, there will be 3 main topics, which is translation, rotation about a fixed axis, and also general plane motion. So this is basically the type of motion that I will cover later. And also after chapter 1, we will go into chapter number 2, which is force and acceleration. As I mentioned earlier, this is dealing with the Newton's second law of motion, F equals to ma. And then finally, in the third subtopic, we will combine 2 methods into one chapter, which is work and energy, and also impulse and momentum, which will be covered in the last chapter, starts from week 9 until week 14. Okay, so why do we learn rigid body planar motion? Because in many of mechanical engineering branches or machines or mechanism that involve engineering work, you can see such motion. For example, this is a simple planar rigid body motion where you have a rotating object, you have a rotating wheel, and you have another point that is moving left and right. So altogether, this belongs to a planar rigid body motion. Okay, this cannot be treated as a particle because this has a rotation, this has a motion left and right. There is a wheel that is rotating. So in particle dynamics, where you learn in diploma, there is no rotation motion. Another example of this kind of mechanism is like the crank motion in the car engine. Okay, you can see that the crank is moving up and down. So the bottom part is rotating. This rod here, piston rod, is also rotating. And then the piston itself is moving up and down. So this is similar to the motion that I have shown in the previous slide. So there are many motions in engineering machines that involves rigid body motion. So that is why we need to learn dynamics. Okay. Before we go into position vector, there are several things that you need to know, that you need to be familiar with. The first and the very important thing is trigonometry. So this, I think you have learned in mathematics, probably during your SPM, or you have also learned maybe in mathematics in UMPSA. So one of the most basic theorem that you need to know is the Pythagoras theorem. This is only applicable for right triangle where you have a 90 degrees angle here. So this is used to calculate the sides. Okay, you have the hypotenuse, you have side A and side B. So the relationship is that A square plus B square is equal to the hypotenuse square. So that is one theorem, Pythagoras theorem, that you need to know. You need to remember, you need to know how to use it. Another important thing, very important, is trigonometric ratio. How do you calculate the side when you have the angle? The Pythagoras theorem does not involve angle, but the trigonometric ratio involves angle. For example, if you want to know the adjacent, you have the hypotenuse, for example, and you have the angle theta. So you can use cosine. For example, the adjacent, you can bring the hypotenuse here, multiplied with the cos theta, you will get the length of the adjacent side. Or you want to know the opposite side of the angle theta. So you can multiply the hypotenuse with the sine of the angle theta. You can bring this hypotenuse here to the left-hand side, and you will get the opposite length. Okay, opposite is equal to the sine theta multiplied with the hypotenuse. Or the adjacent is equal to the cos theta multiplied with the hypotenuse. And also you have tangent punya relationship. Tangent theta is the opposite divided by the adjacent. But the most common one that you will use is sine and cos. So you need to know, if you want to know the adjacent length, what should be multiplied with cos theta or with sine theta, and so on and so forth. So trigonometry, Pythagoras theorem, and trigonometric ratio is very important. So please go back and do some revision on this if you have forgotten about this, and try to make yourself familiar with these two theorem and also trigonometric ratio. Okay. Next one is sine rule. If the previous theorem is only applicable when there is 90 degrees angle in the triangle. So triangle, total angle in the triangle is 180 degrees. So at least one of the angle in the triangle has to be 90 degrees. which we call it as right triangle, then only you can use Pythagoras theorem and the trigonometric ratio. If the triangle does not have 90 degrees angle, but you know the angle A, B, and C. Maybe the angle is 30 degrees, 45, 45, and 45, 45, 90 also. You have anything lah, 70, 80, and 17, 80, and 40, for example. It makes up to 100, sorry, 70, 40, and 30. 70, 80, and 30. So it will become 180 degrees. So if the what do you call, the angle is not 30 degrees, it is not right triangle, then you can use sine rule to find the sides. Okay, for finding the sides. So you have A, side A, divided by the sine of the opposite angle. Opposite angle is the capital letter of A lah. So you can see here, length A divided by sine A, the opposite, is equal to length B divided by sine B, the opposite, is equal to length C divided by sine of the angle C. So this is very important for you to know to find the sides. The rest is not really important, is quite rare that we use in the dynamics class, but sine rule for finding sides is very, very important. So if you are making your notes now, please make sure you write this down. So sine rule is very important. Theorem Pythagoras is very important, and also trigonometric ratio is very important. All these three rules is very important for you to get the length later when you are solving the problems. Cosine rule is quite rare to be used in dynamics, and also for finding angles, you just flip the flip the equation here lah, and it is also not very common, but the most common one is using sine rule. Okay, and then in this chapter 1, we will also use a lot of vector. Okay, so I hope you know what vector is. In mathematics quantity or in physics quantity, we have scalar and also vector. So scalar and vector, what is the difference? Anyone know what is the difference between scalar and vector? Any idea? Scalar versus vector.
For me, scalar is they have only magnitude, but for vector, they have direction and magnitude.
Good. Okay. Both scalar and vector has value. Value means the magnitude lah. It's a number like 10, 10, 20, 30, and so on. So that is the magnitude. But scalar, for example, we say velocity. Scalar is 10 meter per second. But when we write vector, you will also put in the direction. 10 meter per second in which direction? To the right, to the left, going up, going down. So that is the difference between scalar and vector. So in the first chapter, we will use a lot of vector, because when you give a value, let's say 10 meter ke, 10 meter per second ke, 10 meter per second square for acceleration, for example, we need to know what is the direction. So that is why we use vector in the first chapter. So you need to understand what vector is. And then when you understand what vector is, you need to understand the unit vector. This here, let me try to zoom it. Okay. If you see here, this is a three-dimensional. So x-axis is in this direction, and you see the unit vector for x-axis is I. Okay, unit vector for x-axis is I. Unit vector for y-axis is J, and unit vector for z-axis is K. So for example, if you say the velocity is 10I meter per second, which means that the object is traveling 10 meter per second in x-axis. Okay, in x-axis, because it says 10I. So if scalar, you say 10 meter per second velocity. We do not know 10 meter per second ni arah ke mana. Whether it is in x-axis, whether it is in y-axis, whether it is in z-axis. So scalar doesn't give you the full picture of what's going on. But when we put the value, we write the value in vector format, then we know the direction which the object is traveling. So you write down 10j, meaning that the object is traveling in y-axis, probably going upwards, 10j. So here is an example of how you write a vector lah. A is equal to AXI, which means that the quantity ataupun the magnitude in x-axis is written with letter I. The magnitude in y-axis is written with letter J. Magnitude in z-axis is written with letter K. I, J, and K is called unit vector. Okay, unit vector. And when you write something, it is not necessarily only in one axis. You can also have vector in two components. For example, velocity of a car is 5I plus 3J, meaning that the car is moving 5 meter per second to in x-axis and also 3 meter per second in y-axis. So the car is basically traveling a diagonal, for example, in a diagonal angle, because x-axis is to the right, contohnya, and y-axis is pointing up. So when you have two values, it is basically a diagonal motion. So that is an example of how you write a vector punya component. And from a vector, you can calculate the magnitude. So meaning that if you have I and J just now, the velocity is 5I and 3J. So how do you calculate the diagonal punya velocity? Is by squaring the x component, which is I tadi, 5 square, plus the square of y component, which is the 3 just now, 3 square. So 5 square plus 3 square, and then you square root it, you will get the magnitude. Okay, the magnitude. Maybe I will try to write so that you will understand better. So let's say we are talking about V, velocity V. Sorry for the bad handwriting here. I'm writing with my trackpad. So V is, let's say, 5I. The unit vector is written like this. When we write on the paper, is written with I, and also there is a hat, macam topi, on top. Because if you write with computer, then you can write it with bold typeface. Tapi kalau kita tulis on paper, how do we make it bold? So when you write on paper, normally you will write it with the topi symbol to indicate that it is a unit vector. Okay, and then, sorry. Let's go back. Okay. Plus, let me find my pen again. Okay. So 5I plus, okay, 3J. So this is our example just now. 5I plus 3J. So you write J, put dot, and put the hat. Okay. So this is the velocity, 5I and 3J. So how do you draw this? This is probably 5 in x-axis, because this is I component is in x-axis, so this is 5 lah. 5 in x-axis, and then 3 in y-axis, probably shorter lah. 5 is longer, and 3 in y-axis shorter. So this will be 3. Okay. So how is the actual direction of the motion? So bukannya dia mula-mula bergerak ke kanan and then selepas tu dia bergerak naik atas. Tak, dia sebenarnya bergerak secara diagonal. So how do I change the color? Okay, let's get a blue color. So basically the actual direction of motion is you will make a box, a rectangle of this. Okay, like this. Okay. And the actual motion, the actual velocity is pointing here in this direction. So this is the actual velocity V. This is called the magnitude. This is the actual velocity V. Okay, so how do you calculate this V? Okay, this is where this comes. So V is basically equal to, you take the X component, which is 5, okay, and square it, okay, 5 squared. And then you plus, okay, the Y component, which is 3. So Y component 3, and then you also square it. And then you square root everything. Square root everything. This is how you calculate, apa tu? This is how you calculate the magnitude lah. So what you get here is 5 square is 25 plus 3 square is 9, which is 34, square root of 34. Let me try to calculate what is the square root of 34. Anybody can help me calculate the square root of 34? Let me see, where's my calculator? Have you calculated square root of 34?
5.83.
5.83, good. So 5.83 meter per second. So basically, the X value is 5, the Y value is 3, the V value, the diagonal value is 5.83, calculated using this lah, using this magnitude. How do you calculate magnitude? So that is what it means by vector. Okay. And if you have a negative here, it means that the direction is in the opposite direction lah. So let's say this is -5. So instead of pointing to the right, then the vector will be pointing to the left. So itu akan ada different direction of apa tu diagonal of the velocity lah. Okay, so negative and positive signs is also play very important role when it comes to vector. Okay, so let's move on. This is vector analysis. So important thing that you should know is the I, J, and K, which is called the unit vector. This unit vector, okay, I, J, and K. Most commonly, we will use I and J because X and Y. And there is also some calculation in chapter 1 that we will use K as well. Okay, and then you also need to familiarize with calculating the magnitude of apa tu, the magnitude of a parameter lah. When you write in a vector to calculate the magnitude means this one. Okay, and to calculate the magnitude, you use this formula, the square of every component, square of X, square of Y, square of Z, and then square root everything, you will get the magnitude. Okay. And this is not really important. The cross product also very important. Later we will learn about cross product. I don't think that I will cover today. Vector cross product. For example, you have vector A multiply cross product with vector B. It is not simply multiplying like if A is 5, B is 3, you multiply 5 and 3, you get 15. Not like that. In vector, there is a way to do the cross multiplication. We will cover later in the class or in the next class, vector cross product. So I will skip this first vector cross product for today. We will cover later in the class. Okay, and also vector dot product, but this is not really useful in dynamics. We are not really using this a lot, so it is just for you to know, but you will not use it in this class. Okay, so let's go to the position vector. Okay, Position vector. All right. So position vector, we have an object at position A. Imagine there is an object at position A, and O is the origin. O is the origin. I will write it here. O is the origin. Origin, okay? Like that. Okay. And from the origin, we see that point A is 3 meter to the right of origin in x-axis and 4 meter going upwards in y-axis. So how do you write the vector of point A with referring to point O? Point O now is the reference point. The origin is our reference point. So how do we write the position vector? We write it as R. Position vector is given by symbol R. R is referring to position. Okay, R refer to the position. So R of what? R of A. And how do we say that R of A is referring ataupun our reference point is point O? We write it as RA/O. Okay, RA/O. When people see this, they will understand. Oh, you are writing, or you are giving the position of point A with respect to point O. Point O is the origin, is the reference point. So based on the vector that we learned before, how do you write RA/O? With the unit vector. Previously, we learned that unit vector is I, J, and K. I is for X component, J is for Y component, K is for Z component or Z axis. So in this case, 3 meter is in X axis, 4 meter upwards is in Y axis. So how do we write this position vector RA/O? Anyone want to guess? Okay, this is similar to what I shown before. RA/O is 3I plus 4J, and the unit is meter. So you write the unit at the end. Okay, again, I repeat, RA/O, O is the reference point, is 3I because it is 3 meter in x-axis, plus 4J because it is 4 meter in y-axis. 3 meter is positive because x-axis is positive to the right, and y-axis 4 meter is also positive because it is pointing upwards, so it is positive in y-axis. So RA/O is equal to 3I plus 4J. So that is the answer for position vector. Okay, let's try the other way around. So now we want to know R of O. O is no longer our reference point. O is our point of interest. We want to show what is the location of O. But now A becomes our reference point. So you write this as RO/A. Whatever after the slash is the reference point. Is the reference point. So let's write it here. Reference. Okay, I will write reference lah. Okay. A is our reference. So how do you write RO/A now? Anybody want to try? RO/A. Kalau sebelum ni is 3I plus 4J. So what it will become now?
How about
-3, -4.
Yes, good. -3 and -4 because the position of A, the position of O, the position of O from A is 3 meter to the left. Okay, 3 meter to the left is the negative direction of x-axis. So dia akan jadi negative here. And also 4 meter pointing down. Our y-axis is positive pointing up. So 4 meter pointing down is also negative. So you will have two negative signs here, -3I minus 4J. So here what I want to mention is that the sign positive and negative is very important when it comes to vector because the direction, it will totally change the direction. If you refer to here, 3i plus 4j, it will be pointing diagonal up. If you go to here, minus 3i and minus 4j, it will be pointing diagonal down. So very important that you understand or you put the correct sign, positive and negative. Okay, so let's move on to a problem. So now we have two objects ataupun two rods lah, let's call it rods. O to A is one rod, and then dia connect dekat point A, another rod A to B. Okay. So what we want to determine is the position vector of A slash O. O is now the origin here. This is the origin. We want to know point A. Laser pointer. Okay. We want to know point A. So how do you do this? First, you need to draw the position vector so that you will not get confused. So how do you draw the position vector? You will draw from the reference. So if you see here, RA slash O, our reference is O. So you start from O, pointing to A. Okay. Before that, you will need to define the coordinate system lah. So normally we will define X positive ke kanan to the right and Y positive pointing up. Okay. So O to A. Anyone can try to answer here. What is the position vector of RA slash O? How many, what is the component in X-axis? Anyone? In X-axis, berapa? Berapa I?
3i.
3i.
3I. Okay, good. 3I. What about Y-axis? Berapa komponen dalam Y-axis?
0.
0. Good. There is no Y-axis here. So, the answer will be RA slash O equals 3I meter. So, you can have a position vector only one component, only in X-axis. You can have only in Y-axis. You can also have both I and J component. Okay, so that we have answered RA slash O. Now, RB slash A. Okay, the first step, you draw the position vector. How do you draw it? Which one, where is the reference here? Is it point A as the reference or point B as the reference?
Point A.
Point A.
A.
Point A, because point A is after the slash. Okay, so you draw starting from A, going to B. Okay, now, when you have drawn and you see that this is diagonal, so to avoid from making mistake, you draw the X and Y punya line, X and Y component. So you draw one Y component pointing down to the point lah, daripada point A, draw one arrow pointing to B. And then draw another arrow to connect. So you will see now you have made a triangle. Lebih kurang a triangle lah. That's why I said earlier, trigonometry is very important. Okay, so now you can see a triangle. One component of Y is pointing down. Another component in X-axis is pointing to the left. Okay, so how do you get this component? Okay, now this is where trigonometric ratio tadi important ataupun theorem Pythagoras, whatever theorem tadi yang saya cakap important, the three rules tadi very important. So now let's see here the vertical component in y-axis. So we know that this is 2 meter, the hypotenuse, the red color vector, position vector is the hypotenuse. So to get the length here is basically this is the opposite. Tadi if you remember from our slide earlier, the opposite is multiplying the hypotenuse with the sine of theta. So theta is now 60 degrees. So this vertical component is 2, which is the hypotenuse, multiplied with sine theta. So you will get 1.732 meter. Okay. What about the horizontal ataupun komponen yang bawah, X punya komponen? Kalau komponen yang vertical ni sine, the other component will definitely be cos. So you multiply the hypotenuse, which is 2 meter, with cos 60 degrees. you will get 1 meter. Okay, now how do you write? So now we know X component is 1 meter to the left, Y component is 1.732 downwards. How do you write RB/A? Anyone want to try? Macam mana kita nak tulis RB/A?
-1, -1.732.
Negatif. Okay. Negatif and negatif tu betul. Tapi you forgot to mention the unit vector. So kita tak tahu. -1 tu dalam arah mana? -1.732 dalam arah mana? So that is why unit vector is also very important. So you write -1 I because -1 ni dalam x-axis to the left. Jadi dia negatif. -1 I and then 1.732 downwards in y-axis is also negative. So negative 1.732J. So this is how you write RB/A. -1I minus 1.732J. Dekat belakang letak unit dia meter. Kenapa meter? Because unit of length lah. Unit of length is meter. Okay. Let's try another one. Okay, this is now a wheel lah kot. Let's call it a wheel. So you have center point as point A and then you have point B dekat circumference luar wheel tersebut. So what we want is RB/A. Okay. Which one is the reference point in this case?
A.
A is the reference point. Okay. RB/A. A is after the slash, meaning that it is A is the reference point. So reference point, bila kita nak draw the vector, we will start from the reference point. So you will draw an arrow starting from A, pointing to B. Okay. Now we know this is a 30 degrees angle. So we can then draw the X and Y component. So you draw one X component will be to the left and then we will have another Y component ke atas. Macam ni, like this. Okay. Alright. So how do we calculate? We know the hypotenuse. The red color line is 0.5. We know the theta, the angle is 30 degrees. So the horizontal component, x-axis to the left. Macam mana nak calculate? 0.5 darab dengan apa? Darab dengan sin 30 atau darab dengan cos 30? Which one?
Cos.
Cos 30. Good. So this datang daripada trigonometric ratio tadilah. Okay, so 0.5 cos 30 untuk horizontal component, which is the x-axis. So you will get 0.433 meter. And then for the vertical component, kalau yang bawah dah cos 30, yang vertical will be 0.5 sin 30 degrees, you will get 0.25. So combine kedua-duanya, you will see that X component is to the left, which is negative. Tapi Y component dia ke atas, so positive. So you will have RB/A negative 0.433I plus 0.25J. Okay. So this is the position vector, position of B with respect to A. Okay. Let's go to the next one. Okay. We have another two rods here. This is point O. Huruf O tertinggal kat sini. O to A to B. Okay, so now what we want is determine RA/O, meaning that O is the reference point pointing to A. So you draw that first, the position vector. Okay, this is straight to the point. You do not have to calculate. You can see the value 3 here. How do you write RA/O? How do you write RA/O?
3J meter.
3J, good. Because it is in y-axis, so RA/O is 3J meter. Okay. Then RB/A. Okay, look at what is after the slash. The slash which is point A. So A is the reference point and B is the arrowhead punya point lah. So we draw the arrow from A going to B. Okay, A to B. All right. So now, what will be the X and Y component in this case? Okay, kalau kita tak draw apa tu? Kita tak draw ni. By looking at this, you should be able to get what is X and what is Y component. I component dia apa?
4.
4. I component you boleh dapat daripada bawah ni, 4 meter. And J component is basically this one, 3 meter. So, it is basically 4I. Okay, so kalau kita nak draw supaya you tak apa tu, pointer, pen color, saya ambil, okay, green lah, right. So, your X component will be this way. Okay, sampai ke B. This is your X component. So, dia adalah sama panjang dengan 4 meter ni lah. And then your Y component is pointing down. It's pointing down to B. And the length is sama dengan 3 meter. So, straight away, without having to calculate, you will get 4I positive. Tapi 3J is negative because it is pointing downwards. So your goal is when you have your position vector diagonal macam ni, you need to get the triangle. So bila you lukis triangle ni, you akan nampak what is the apa tu I component and what is the J component. Okay. So maybe the last example for today and the tutorial that I have shared with you, you will try to do it at home. Kita akan discuss dalam next class on Wednesday. Okay, so determine, sekarang ada three rods lah connected to each other. OA, AB, BC. Okay, so first we want RA/O, meaning that it starts from O pointing to, it starts from O pointing to A, betul. O is the origin here lah. Okay, so O pointing to A. Okay, we know the length of OA 2 meter is given here. So we can draw our triangle lah, make a triangle so that you will not get confused. Okay, so what is this? The vertical Y punya axis. How do you calculate that? You have the angle 30 degrees here. You know the hypotenuse, red color, 2 meter. So, macam mana? 2 darab dengan sin 30 or 2 darab cos 30? Which one?
Cos 30.
Cos 30, good. Okay, because this is now the adjacent, bukan opposite. Okay, this is the angle 30 degrees. Adjacent adalah yang sebelah angle. Sebelah angle is this one. Yang ini adalah opposite. So, RA/O is 2 sin 30, positif sebab dia ke atas. And then untuk 2 sin 30 yang atas ini, this one, I component, and 2 cos 30 is the J component, apa tu, yang vertical. So you will get the value 1I untuk atas ini, and then plus 1.732J untuk vertical punya component. Okay, and then RB/A. So now the reference point is A. Apa yang di belakang slash is the reference point. So you draw arrows starting from A pointing to B. This is straightforward. There is no need to multiply with angle. You have 3 meter panjang dia, but we need to know 3 meter ni dalam X ataupun dalam Y axis. So this is definitely in X axis. So RB/A is 3I meter. Okay. And the last one, RB/C. Okay, so now reference point is point C because it is after the slash. So we will draw arrow starting from C, pointing upwards to point B. Okay. So what will be this value? RC/B. Anyone? RB/C, sorry. RB/C. What is the value?
2J.
2J. Mana dapat 2? 2 here is the OA tau, yang saya ingat tu. So, BC punya panjang is basically sama dengan panjang ni. Kan? Sama dengan panjang this component, which is, this is the J component, yang ini. 2 cos 30, which the value is basically 1.732. So, this is basically 2 cos 30 and equals to 1.732J. So be very careful. Jangan tersilap ambil value 2 ni because 2 meter ni adalah yang apa tu diagonal punya component. Okay? Alright. So any questions so far? We have done about 4 questions on position vector. We will continue the rest. Ada a few more tutorials. I have also given you in the WhatsApp group. So try to do the position vector at home. In the next class on Wednesday, kita akan sambung with the answers of the tutorial position vector, and we will continue with the actual calculation lah on the problem. So now kita hanya belajar the position vector. Later we will see when the object is moving, how do we calculate velocity of point A, velocity of B, what is the rotation, and so on. So any question before I end the class for today? Okay, I hope that everything is clear. I will share the recording in Kalam and also in the WhatsApp group. I will upload in YouTube and then I will share the link in Kalam and also in WhatsApp group. Okay, thank you for joining the class today. I will see you again on Wednesday, this coming Wednesday, also same time, 8:30 AM. Okay, Assalamualaikum and have a good day.
Wassalam. Thank you, sir.
Welcome.
Waalaikumsalam. Thank you, sir.
Thank you, sir.
Waalaikumsalam warahmatullahi